Alright guys, if a right circular cylinder of height 10 is inscribed in a sphere of radius 6, what is the volume of the cylinder? This is kind of a tricky question. So first of all, we have to know what inscribed is, and we talked about that earlier in the year. Inscribed essentially means you've got a situation like this. So you've got one shape inside another where the vertices are on the outer shape. So the vertices of the inner shape are on the outer shape, or points on the outer shape. So this is the way you have to visualize this. You have a side view of the cylinder. If we were to tilt it kind of toward us, you would start to see the circle a little bit show up. You know, essentially your top kind of looks like that, and it would go back a little bit like this. But we have a perfect side view, and so because of that, it's going to look like a rectangle. All right, so what they give us is the cylinder has a height of 10. So if I draw this dot perfectly in the center of the cylinder and the sphere, we know that this is going to have a length of 5, so half the height is 5. And if you want to, you can throw the other piece of that height down there. That's also going to be 5. All right, so height of 10. Radius of 6 on the sphere means that if we take the length from the center point to any point on the sphere, it's going to be 6. So if I draw a line out, there's a radius of the sphere. That's going to have a distance of 6. Okay? Well, but what's the most useful piece here? We want to know what the volume of the cylinder is. So we want a radius that's going to help us figure out what the volume of that cylinder is. And notice we've got this little guy up here. This little piece up here is going to be worth 1. Not sure how that's necessarily useful, but what you can do is, I know that any radius can be drawn from the center to a point on the circle, or on the sphere, I should say. And so now I've got this right triangle here, and we can simplify this a little bit. This right triangle has that length is 5, that length is 6 because it's the radius. And we can now figure out what this distance is. And so because of that, we can use Pythagorean theorem. Because of that, we can find the radius of the base of the cylinder, and therefore find the volume of the cylinder. All right, so let's go ahead and go through and do that. We've got 6 squared minus 5 squared, the square root of that. It's going to be equal to, I guess, 1/2 r. So whatever, we'll just call that x for this particular case. But 6 squared is 36 minus 25, that's root 11. It's going to be half the radius, so 2 root 11. I'm sorry, that will be the radius. Get rid of this. So that will be the radius. We'll call that the radius. So if that's the radius, we can then go find the volume of this cylinder by finding the area of the base and multiplying it by the height. So the area of the base, we know the base is a circle on a cylinder. Area of the circle is pi r squared. So that's pi times root 11 squared. And then multiplied by the height, which is given up here by 10. So go through and solve. You end up with 11 times 10. That's 110 pi. Units, whatever our units were. I don't think they're given up there. Units, I'm sorry, cubed. Units cubed.